Hi everyone, this is Priya from Department of Information Technology in SNS College of Technology. So today we are going to discuss the topic about process scheduling and synchronization in Unit 2 of Operating Systems. Under this unit, we are going to discuss the topic about deadlock detection recovery. So let's recall the session before we enter to the today's session. The last class we have discussed about last session we have discussed about deadlock occurs when processor wait forever and prevention avoids deadlock and detection allows deadlock to occur. So these are all the things we have discussed in the last session, and the topics for discussion on today's session is deadlock detection, detection algorithms, resource allocation graph, and recovery techniques. So let's explore the thing we are going to discuss the today's session. System allows deadlock, OS checks for deadlock, recovery is applied. This is the things we are going to discuss the today's session, and why deadlock detection is used. Prevention limit resource usage. Detection improves flexibility, common in real system. While the single resource can requested by multiple process, we have to limit that particular resource usage to avoid the deadlock happen. So while using detection, it improves flexibility of the system. It is mostly used in the real-time systems. So this is the deadlock detection, and detection, why we are giving importance for this detection is OS periodically checks system either detection is deadlock is happened or not. For that we are using deadlock detection, and for deadlock detection we are using many algorithms for detecting algorithms and finds deadlock cycles. Deadlock is a formation of cycle which is resource 1 is assigned to process P1, and the same resource 1 is requested for P2 process P2, and resource 2 is assigned for process P2, but the same resource R2 is requested by P1. There is due to this incident the cycle will happen. So this is deadlock. Resource allocation graph. So nodes represent processes and resources. Cycle indicates deadlock used for single instance resources. So nodes represent processes and resources. Deadlock means it should always in the form of cycle. So it is used for single instance resources. So this is resource allocation graph. The deadlock detection algorithm is used for multiple instances similar to Banker's algorithm and checks unsafe state. While the system is in unsafe state, which means which deadlock is happened, and some kind of resources are waiting for the long time. So some kind of processor waiting for a long time for the particular resources means that is unsafe state. The detection algorithm is used to check the system state. That is deadlock detection algorithm. And when to detect, we have to check uh, the process for each and every request which is done by process, and fix the intervals. So one process is assigned for resource 1 means we have to fix the duration for that particular resources which is allocated to the particular process, so that particular resources can be allocated for the some other process after the duration of some time. So low CPU utilization will happen while deadlock is occurred. So this is the thing we have to detect deadlock. And recovery from deadlock means action after detection. System must break deadlock. Two approaches or happen. So action after detection means if we found a deadlock by using detection algorithm, what kind of actions we are going to perform, and the system must break that particular deadlock. And two approaches are here to break the deadlock. process termination. Once we find that deadlock is happened, we have to abort all deadlocked processes and abort one at a time. Simple but costly. So resource preemption, forcefully take resources, roll back processes, avoid starvation. So issues in recovery means victim selection. We have to find a particular resources and process uh, which is uh, which is the reason to make the deadlock cycle. We have to select that particular victim and roll back cost and starvation risk. So these are real-time applications or database systems, operating systems, and transaction system. This is the thing. And let's summarize: detection allows deadlocks, OS finds cycles, recoveries resolve deadlock. Thank you.